Welcome back to the Information Week News Desk, coming to you live from Interop ITX in Las Vegas. I'm Sarah Peters. We have another Information Week IT Excellence Award finalist for you now, and in fact, got second in the infrastructure category. Our next guest is Chief Engineer of Infrastructure for Mitre, Mr. Jim Treadway.
Hi,
Jim,
Sarah.
thank you so much for
Thanks.
being here. So before we talk about the solution that won you this honor, why don't you tell me about the problem that you were trying to solve?
Sure. Well, Mitre, a big part of what we do is research and heavy analysis, and so over the past several years, the scale of what we're doing from a compute analytic perspective has been growing significantly, and it got to the point where we had exceeded the capacity of a lot of our existing data centers, and so we really needed to find a solution of how to support the business mission, but doing that economically. We looked initially at kind of the traditional paths, looking at colo and cloud, and for the kinds of workloads that we're driving, those aren't always so cost effective, so we really needed to kind of think a little more creatively of how we're going to bring much higher compute capacities, much higher power and cooling densities, and doing that at a lower cost to operate, and that was a big challenge for us. So we took a lot of time to really start thinking about how we were going to solve that problem and be able to bring the kind of services to our business units that they needed to have in order to continue doing the work that Mitre does. We wound up really stepping back a bit and really starting to think about this as a physics problem, really. Traditional data centers, you're really just moving heat energy from point A to point B.
Yeah, right.
And I think traditionally, a lot of it comes from more of a building HVAC kind of perspective of how to cool a large space like a Walmart. That's not very economical. The reality is that air is not a very good conductor of heat energy. It's an insulator.
Yeah.
So we started thinking about, okay, how can we look at this in a different way? We looked at water solutions, which there are plenty of on the market. But we also started looking outside our kind of comfort space and looking what are other companies doing that have been trying to solve these higher density problems. And we find that there are solutions out there that are circulating liquid refrigerant and really thinking it more as how to capture the heat. Instead of trying to dump the heat in the room and cool it, why not just capture it and not heat the room in the first place and more directly transfer that heat energy into an engineered substance like R134A. So we took a lot of time to think about all these different solutions, air, water, and refrigerant-based solutions, rear door, in-row, there's so many different solutions on the market. So we took the time to really step back and look at them in terms of what are the real efficiencies, what are the CapEx, what is the OpEx, and what's the most efficient way we could find to solve this problem. And so we wound up doing a lot of work for almost a year and a half to do that heavy analysis and really understand what the right choice was for us to move forward. Once we'd solved kind of the cooling situation by looking at pumped refrigerant rear doors, we started realizing that we also had a power challenge. We're now bringing close to 50 amps into each cabinet. That's really challenging to do when you're dealing with traditional 240 volt in the United States. So we had been working with some external entities who kind of shared some thoughts of really looking at, again, non-traditional sources of methodologies, and we find that in Europe, the standard's been on a 415 volt standard for a long time. I'm not sure why it hasn't been adopted in the United States, but it's common in Europe and Japan. So we basically looked at that and again found that it's a more efficient way of moving electrons basically by going to a 415 volt standard. So we basically did some work to really understand that. Had to definitely work with our engineering folks to work through some of the change issues. It's a little, it's a fairly conservative space when you start dealing with high voltages.
Yeah. And
so you have life safety issues that people are concerned about. So we really had to work with them, bring a lot of data, and again, find ways to make it more comfortable for them to adopt that kind of change.
Now, you told me that you maybe we're a little bit lucky in the kinds of people that you have there. Not just because of the culture, the sort of research-based culture that you have, but also because of some of the data center people that you have both a mechanical engineering and data scientist background.
We were very fortunate in that respect that we have some very skilled staff who have very strong backgrounds in analytics and data science and also had backgrounds in mechanical engineering. So it really gave us a leg up of being able to look at this problem not just from the IT side of the house, but really try to look at the holistic solution of, what is a data center? It's not just power and cooling and cabinets. It has to, a lot of it, the bulk of it is for IT.
Yeah.
So by being able to bring those kinds of analysis capabilities and blend them, it allowed us to really take control and really drive the solution set by being able to go very deep and understand what the option space really was, and even looking beyond kind of the traditional HVAC approach to data center design and start thinking it more have an integrated IT solution and put it all together holistically. I think that one of the outcomes that came from that has been very fortunate is that it's really brought our IT house and our facilities team together now. Traditionally, you'll see that facilities groups are kind of separate from IT and vice versa. We really now have kind of a unified team now, so it's basically, we're operating the data center, it has an on-prem colo facility, and it has a kind of a co-ownership model now where IT and facilities operate this jointly, and that was a really good outcome for us.
Well, really quickly, because we're running out of time,
Sure.
but what kind of cost savings have you had compared to that colo thing that you might have considered?
So when you look at kind of the loads we're having, we looked about over 24 colo providers that could support the kind of densities that we needed. The cheapest we could find was basically around the $250 per kilowatt per month, and that dollars per kilowatt per month became the metric that was most important to us. That was my real, how big of a check am I going to have to write every month to operate this facility? So bringing OpEx down by going with more efficient power and cooling technologies, we've been able to do that now for about $150 a kilowatt per month, which is, almost, depending on the colo, 40 to 60% cheaper than anything we could do off-prem.
Wow.
So that's translated to almost a 90% reduction in the cost of cooling in our data center, and you look at that as an aggregate, it's from the chiller plant all the way to the servers, it was an aggregate reduction of 20% of the entire data center operational cost, which is huge. So we've been very pleased with the economic benefits of just being a lot more efficient.
Well, congratulations on that, and congratulations on your award.
Thanks.
Thank you so much, Jim.
Thanks, Sarah.
Pleasure having you here.
Thanks.
That's Jim Treadway from Mitre. We will be right back with more from the Information Week News Desk from Interop ITX after this.